In this video, I'm going to be working through BC Quiz 9.4, Form M. So this is one you maybe worked in groups or something, because I was out. And this is mostly long division and complete square, but I think there's a couple other types of integrals in here as well. So first we're going to find the value of this integral, and we're going to show the worth that leads to our answer. And since I see a quadratic on top and linear on bottom, this is a bigger on top fraction, I need to use long division. Okay, but in this class, we can almost always use synthetic division, so that's what I'm going to set up for. 3x to the 2, negative 2x to the 1, negative 9. We're going to divide by x plus 2, so we're going to put a negative 2 out there, drop this down, multiply, add. Wait, 16 minus 9 is 7. Okay, I'm going to double check that because those are some weird numbers, but 3 minus 2 minus 9, the work there all looks right. Okay, so what I'm doing is I'm integrating from negative 1 to 1 on 3x minus 8 plus 7 over the divisor, x plus 2. I'm going to find an antiderivative. 7 log absolute value of x plus 2 as x runs from negative 1 to 1. Okay. All right, so when I plug in 1, I'm going to have 3 halves minus 8 plus 7 of the natural log of 3. And then I'll be subtracting what happens when I plug in negative 1, so that would be I get a 3 halves there. Negative 1 times 8 will be plus 8. And then 7 log of 1, that's a 0. Okay, so I've got all of that. Oh yeah, and this actually ends up being pretty easy to add together once I get all the terms written down, because I have 3 halves minus 3 halves, that goes away. Negative 8 minus another 8 is negative 16. So I'd have negative 16 plus 7 natural log of 3. Right, now this one. Suppose f of x equals 1 over negative x squared plus 6x minus 10. Well, the first thing I'm interested in doing is rewriting this so that the leading coefficient of the denominator is not negative, because I would have a hard time looking at this and just figuring out if it was factorable. I don't know, maybe you'd have a better time, but for me, it's like with that negative there, I don't like that. So what I'm going to do is I'm going to factor out the negative and kind of apply it to the numerator. So that'll be negative 1 over positive x squared, negative 6x, and positive 10. And I'm thinking about factors of 10, that's 5 and 2, and 10 and 1. Neither of those are going to add up to negative 6. It's like, it's not factorable. Looks like a mistake. Okay, must be arctangent. So what I'm going to do is say, all right, antiderivative. Well, maybe I'll actually say, all right, x squared minus 6x plus 9 is a perfect square. And I'm bigger than a perfect square by exactly 1, so that's a pretty good sign. So x minus 3 squared is x squared minus 6x plus 9, and I've got this extra 1 hanging around there. So an antiderivative for f of x with respect to x is going to be, well, arctangent, or maybe negative arctangent, because of that negative 1 in the numerator. Negative arctangent of x minus 3 plus some constant c. All right. Here we've got the graph of y equals f of x. Find the value of this integral here. Okay, and I think this one we want to just do it by finding an antiderivative and just, kind of thinking critically about it. An antiderivative for f prime is going to be f, so I would, my initial hypothesis would be f of 1/2 x. But then I think about it in terms of the chain rule, because I got a linear inside of the composition of functions, and I would be multiplying by 1/2 after the fact, so I'll probably need to prepare for that by multiplying by 2, dividing by the half. Okay, so if I think about taking the derivative of 2f of 1/2 x, that will be indeed f prime of 1/2 x. And so I'm going to let x run from 2 up to 4. Now, if you wanted to do a u substitution, that would be fine. Just remember to convert the bounds, because this is getting at a multiple choice question, and they will definitely be ready for your error there. All right, so this is going to equal 2 times f of half of 4 minus 2 times f of half of 2. And so 2f of 2 is going to be 6 minus 2f of 1 would be negative 2. So I'm getting a total of 8 there. All right, it is known that 1/2 of the log of x squared plus 1 is an antiderivative for x over x squared plus 1. That must be something that will be helpful to me later. Use long division to find the integral of x to the 3 over x squared plus 1. Okay, this is one that, I probably wouldn't put one like this on the test, but I do want you to be aware of this type of long division as well, right? We can't use synthetic for a denominator of x squared plus 1. So I'm going to go, and I'm going to do the long division, but I think I'm going to need a thinner pen. Alright, so I'm interested in taking x to the third and dividing by, that's probably not going to work. I need to just move all of this down. Let's see, just move that there and say, alright, divided by x squared plus 1. Alright, what we're going to need to do is put in placeholders for all these things that we're missing. Fortunately, I asked myself, what do I need to multiply x squared by to get x to the 3? That would be x, and then I will distribute that back around. X to the 3 plus an x. Oh, I guess I didn't need all of that stuff, but, maybe it helps you, kind of keep the structure straight. I'm going to subtract those things here. I'd get 0, 0x squared minus an x. Bring down that 0. And then I ask myself, what do I multiply x squared by to get 0x squared? That's 0. What do I multiply x squared by to get negative x? That'll be 1 over x. Okay, so I'm into the realm of the remainder. So I think the remainder is just going to be minus x. Okay, so minus x over x squared plus 1. And if you think about it, would I be, yeah, this is going to work. You could think about this like combining with a common denominator. I'd have x to the third plus x divided by x squared plus 1. That's what x is. Minus the x. Okay, I'd end up with x to the thirds I had originally. So if I want an antiderivative, I'm really taking an antiderivative of x minus x over x squared plus 1 dx. And because I just wanted this to be a long division problem, I didn't also want it to be a substitution problem. I'm going to remind you of this fact that we just got. And, also remind you of the fact that, oh, there we go. It just gave us that answer. All right, so that's good. We can work with this. So I'm going to say this antiderivative is going to be 1/2 x squared plus, okay, 1/2 natural log of x squared plus 1. Okay, you might be wondering, where's the absolute value? Well, x squared plus 1 is always a positive number, so I don't think it's going to be necessary. And then plus some constant c. All right, the last one I've got for you is one where we're just going to do algebra on this. We're just going to use the distributive property. So we're going to say, all right, this is 1 over x cubed. It's still anti-differentiating. Multiplied across the x squared and the positive 1. And if I was to distribute that, x to the 2 divided by x to the 3, that's x to the negative 1. Plus, and I'll distribute the x to the negative 3 on the 1, and I'll just have x to the negative 3. And then I'm just going to use the power rule, right? If I tried to do the power rule on x to the negative 1, I wouldn't get very far. I'd be like, oh, that's 1 over x. Its antiderivative is natural log of the absolute value of x. Okay, then I'm going to add 1 to the power and divide by the new power and add c, right? And I think that's it. Yep, that is the bottom of the quiz. So that's going to be all for this video. Thanks for watching.